prove that a equals pi r squared with calculus. So the Cartesian equation is x squared plus y squared equals r squared. So rearranging for y equals the square root of r squared minus x squared. So we're going to integrate between 0 and radius of this with regards to x. Then we're going to use the substitution x equals r sine theta. So we need to find dx because we need to substitute it in. So dx equals r cos theta with regards to theta. So we're going to sub all of this in. And also we've got to think, what are our bounds now? So when x equals 0, our theta is going to equal 0. So x equals 0, theta equals 0. Because we have to do this with substitution. X equals r, theta equals pi over 2. Because the inverse sine of 1 is pi over 2. So now our new bounds are pi over 2 and 0. And we're going to substitute this in. So r squared minus x squared, which is now r squared sine squared theta, times by dx, which is now r cos theta times d theta. And right, so this is between here and here, which is a quarter circle. So we're going to times the entire thing by 4, which is nice. This is going well. So now we've got 4 times, well, before we do that actually, we're going to rewrite this. So how can we rewrite r squared minus r squared sine squared theta a little bit nicer? Well, we can take the r squared out. So this is going to be r squared, and we're going to leave with 1 of those in each one, minus the sine squared theta. Very nice. So this looks a little bit like an identity we can use, which is r squared lots of cos squared theta, using sine squared theta plus cos squared theta equals 1. So that's square rooted. So now we've got 4 times the integral of pi over 2, 0. R squared cos squared theta, all in rooted, is r cos theta times r cos theta times d theta. So here we can take out the r squared here. So we've got 4 r squared, because we've got an r in both of them, times the integral between pi over 2 and 0 of cos squared theta times d theta. I'm getting very low on the board, so I'm going to start rewriting stuff up here. So we've got 4r squared times this integral. So now we need to rewrite cos squared theta in a way that we can integrate, which, using the identity, is a half plus cos 2 theta over 2. So now we've got 4r squared times the integral between pi over 2 and 0 of 1/2 plus cos 2 theta over 2 d theta. So now this is 4r squared lots of half is theta over 2. Cos 2 theta goes to sine 2 theta, divide it by 2, so over 4. So now we can simplify this, and that is between pi over 2 and 0. So 4 divides through by 2, so that's going to go to 2 theta, leaving the r squared on the outside. 2 theta plus 4 is just going to cancel with the 4, plus sine 2 theta between pi over 2 and 0. So r squared is going to be times by 2 times pi over 2 is just 2 pi. Sorry, just pi. Plus sine 2 theta, so sine pi is just 0, and then 0 is 2 times 0, and then sine times 2 lots of 0 is just 0, which is going to leave us with our famed pi r squared, which is that area. Very nice.